Hey guys, so I'm gonna make this video today for multiplying polynomials. We're gonna look at two different methods for multiplying polynomials. We'll look at the FOIL or the distribution method, and we'll look at the box method. So the nice thing is you can really use either method, whichever one you prefer for all polynomials. You just have to be really careful to make sure that you are fully distributing no matter which method you choose to use. So we're going to start here with just a couple of smaller examples. So at this point, you should have gone through your polynomial vocabulary. So we should know what a monomial, binomial, trinomial are. And so we're going to use some of those terms as we go through here. So let's start with something simple, something like 2x times 3x to the fourth. So this is a monomial times a monomial. And what we can do here is just distribute. This would be a weird one to use the box method for. We would use the FOIL method for this one. So I would just distribute that in, 2 times 3 being 6, and x times x to the fourth becoming x to the fifth power, because remember, when we multiply variables, we add their exponents, and there's that invisible hidden 1 there as an exponent for our 2x. So that's one, that would be our first, most simple example. To take that up a notch with our distribution or FOIL method, we might have something like negative 7x times 3x minus 2y. So you can definitely have multiple variables. So now when we distribute, not only are we distributing to that first term, we are also distributing, we're distributing to all terms inside of that parentheses. So we would do negative 7x times 3x, which would give us negative 21x squared, and negative 7x times negative 2y. Take that negative, take the sign that's directly in front of that term, and we would get plus, because negative times negative, 14xy. So both of these are ones where I would always use the distribution method, which is what we just showed here. Once you get a little bit bigger than this, that's when you start kind of being able to decide which method is more accurate for you. Do you want to use the box method, which we'll show, or do you want to use the distribution method, which we will also show? So if we go up to our third example is a binomial, 5x plus 2, times another binomial, 3x minus 4. And what I'll do for this one is I'll actually show you both of the methods. We'll start with our distribution, also known as FOIL, but we'll start with the distribution method, and we'll also show the box method, and you'll see that it's exactly the same, or it gets us the same answer, and actually every step of the way we will see the same terms. So if I'm using the distribution method, when we say distribution, what we're really saying is I need to distribute everything in my first set of, in my first polynomials, or my first binomial, to everything in my second binomial. So that means the 5x has to multiply to the 3x and to the negative 4. My 2 has to multiply to the 3x and the negative 4. So here I would have 5x times 3x, which would give me 15x squared, 5x times negative 4, which would give me minus 20x, 2 times 3x, which would give me plus 6x, 2 times negative 4, which would give me minus 8. From here, I would want to combine any like terms I have, which in this case are these middle two terms, both of those x's. So 15x squared, and I have negative 20x plus 6x would give me minus 14x, and then bring down that minus 8 at the end. So that's my FOIL method. The FOIL or the distribution method is a quick and simple method to use when I have a binomial times a binomial. Again, I could also use the box method, which I'll show you here as well. So if I was doing the same problem with the box method, If you think back to biology, this is going to be kind of like a Punnett square in biology when you were doing the genes and recessive and gosh, I can't remember the other word, but your genes when it came to the Punnett squares. So what I would do is I'd take my first set, so that was my, let's just separate this here. Same problem, 5x plus 2 times 3x minus 4. I would take my first binomial and I would break that up into its two terms across the top of the box. And then down the side of the box, I would put my second binomial, so 3x minus 4. And then inside of these pieces is where I'm going to do my multiplication. So in this first box, I'm going to do 5x times 3x here, which would give me 15x squared. Then in this box, I would do 3x times 2, which would give me a positive 6x. Here, 5x times negative 4, which would give me negative 20x. And then finally, negative 4 times 2, which would give me negative 8. Notice, if you look at what we had here, and if you look at the terms inside of our box, we actually have exactly the same terms because we did the same multiplication. We just have a different method, right? There's multiple different methods we can use when it comes to most of our math. And so this is just two different methods we can use to get to the same place, allowing us to make sure we are doing our full distribution. From here now that I've finished the multiplication, I'm done with those outside, I've done the multiplication. So I'm done with the 5x plus 2, and I'm done with the 3x minus 4. So now I want to look at any like terms I have inside. So usually, unless something is weird with the setup of those problems, usually your like terms are going to be on a diagonal, like we have here. So we've got negative 20x plus 6x, just like we had up here, which would give me negative 14x. So I'm just combining those like I did before. And then I just need to write out my answer, always starting with the largest exponent. So I would have that 15x squared minus 14x minus 8. And notice again here, it doesn't matter which of those methods we use, as long as we do all of the math accurately, we are getting to the same answer because we did the full distribution for both of those. So when I have, again, a binomial times a binomial, personally, I prefer distribution because it's a little bit quicker. But once you start getting bigger than a binomial times a binomial, that's where I prefer the box method. I find that it helps me to not miss out on terms accidentally, and really helps me organize my work better once things start to get bigger. So let's look at one that's a little bit bigger here. Let's look at a binomial times a trinomial. So we would have x minus 3 times 5x squared minus 9x plus 2. So again, I can use my distribution method here, but now I'm distributing x minus 3 to everything inside of that trinomial. So those arrows start to get a little messy. So this is a place where I prefer to use the box method. So when I do that, I would, just like I did before, put my x minus 3 across the top, so just breaking it up by the terms. And then down the side, I have 5x squared minus 9x plus 2. So notice that I put my plus and my minus no matter what after the first term of each one, just to make sure that I remember what sign that was. And then I fill in with my multiplication. So 5x squared times x would give me 5x cubed. Negative 9x times x, negative 9x squared, 2 times x gives me a positive 2x. The nice thing with the box method too is you can really go in whatever order you want, and it really keeps everything kind of, again, organized well. So here again, I've got negative 3 times 5x squared, so negative 15x squared. Negative 3 times negative 9x will give me a positive 27x, and negative 3 times 2 would give me a negative 6. So I've done all of my multiplication, which means I have finished with both of those outsides, and now I'm just looking for like terms across the inside. So in this case, I've got multiple sets of like terms. I've got my x squareds here, and I've got my x's here. So I've got two things I need to combine. So 27x plus 2x would give me a positive 29x, and negative 9x squared minus 15x squared would give me a negative 24x squared. So now all I have to do is write out my final answer. Again, starting out with your largest exponent first, we have 5x cubed minus 24x squared plus 29x minus 6. And that would get us our product, or our answer for this multiplication problem up here. Now I'm going to leave the answer down here, but I'm going to erase this part and show you the distribution method that we would use. So again, even if it seems a little bit shorter for the distribution method, I prefer this way for myself because I just find that even if the distribution method is quicker, this helps me be more consistently accurate. And while speed is important in mathematics, accuracy is also incredibly important when it comes to basic computations like this. So again, leaving the answer so that we know we can get to the same place. If I'm coming back up here again, I would do my x times 5x squared, which would give me my 5x to the third, x times negative 9x minus 9x squared, and then x times 2 plus 2x. Then I would do my negative 3, and this is where I would move to the bottom. Negative 3 times 5x squared would be minus 15x squared. Negative 3 times negative 9x would be plus 27x, and negative 3 times 2 would be negative 6. From here, I need to, again, combine those like terms. So I have my 2x and my 27x. I have my negative 9x and my negative 9x squared and negative 15x squared. So 5x cubed, combining those, minus 24x squared, combining those, plus 29x minus 6. So notice here again, we get exactly the same answer. But this starts to get kind of messy. And what often happens is people will either multiply the same thing twice, or they will completely miss multiplying something. Most commonly, I see people miss out on that middle term of the trinomial. So I find it, again, myself, I'm most accurate with the box method. But if you can be accurate with the distribution method, you're welcome to use that as well. So to just push ourselves a little bit further is one place where I would almost insist that you use the box method. And that's anything bigger than a binomial times a trinomial. So our last example is going to be a trinomial times a trinomial. So we have 3n squared minus 7n plus 1 times n squared plus 2n minus 3. So you can see here, if we started to try to use the distribution method with our arrows, we would have 3 sets of arrows, right? Because we'd have one set from the 3n squared, one from the negative 7n, and one from the plus 1. So this is definitely a place where I almost insist that you use the box method, just because it is so messy and so prone to missing something if you are using the distribution method. So for my box method, setting up my first 3n squared minus 7n plus 1, and then down the side, n squared plus 2n minus 3 there. And so yes, there's a lot of multiplication, but we know it's the same amount of multiplication as if we were to do the distribution method. So let's start that multiplication. 3n squared times n squared would give me 3n to the 4th. 3n squared times 2n would give me positive 6n to the 3rd. 3n squared times negative 3 would give me negative 9n squared. And then going into my negative 7n, I would have here negative 7n to the 3rd, negative 14n squared, and plus 21n. And then finally, plus n squared, plus 2n, and minus 3. So done with those outsides. Now looking for my like terms. I've got my n cubes, n cubed, n squared, and n. Okay, so here I would have, so here, let's just go from the beginning here. So we'd have 3n to the 4th. And then if I combine these here, actually I should have done that in red. Let's do that in red. If I combine these here, I have positive 6n cubed minus 7n cubed. So that's minus n cubed, right? Because it's negative 1n cubed. Negative 9 minus 14 plus 1. I'll do this now. So that's a negative 23 plus 1. So that's negative 22 n squared. Positive 21 plus 2, so plus 23n. And then finally, minus 3 at the end. So I know that trinomial times trinomial takes a lot of time, and it takes a lot of space on our paper. We have to be extra careful. But again, the box method is going to be your quickest way to multiply with those.